Alright guys, this is our final video for Unit 4.1. Let's talk about the properties of logarithms. So when you are finding the product, it is going to look as though we are multiplying, and then when you separate it, it would be log b of m plus log b of n. This is going to be very beneficial. I'm just going to hold this up for a second. Feel free to pause and write this information down if you don't already have it. This is an example, of course, but these are the rules that have to be followed. So multiplying is actually adding when you break it apart. Dividing is actually subtracting when it's broken down. And then when we taking the power, you're moving this into the front to create n times log bm. And then if log bm is equal to log bn, then m is equal to n, because the log b's would then cancel out, and it would just be m is equal to n. And that information is going to be very important. So on these, we're going to be expanding the expressions using properties. We're not solving anything, we're just expanding, and then we're going to do the reverse down here. So we have log 5 of 7 times x squared times the square root of y. So we're multiplying here. That's going to turn it into addition. So we're going to break it out. Let's see, log 5 of 7 plus log 5 of x squared plus log 5 of y, square root of y, but I'm actually going to write that as 1/2 because we still have one more step. Now this could be expanded if we didn't have exponents for these x and y values, but because of that we also have to incorporate the power definition here, and we have to move that exponent to the front of those logs. So we have log 5 of 7 is good, we don't have to change it. But we have to pull that 2 to the front, 2 times the log 5 of x, and then we have to move that 1/2 to the front as well. So we have 1/2 log 5 of y, and this is going to be your expanded version here. All right, so on B, we have a little bit of multiplication. We also have a little bit of division. So I'm going to start with ln of x to the 1/2. I always recommend just writing those roots as exponent fractions. That's just going to make things a little bit easier. So then we're subtracting ln of y to the third, but these are being multiplied. So I'm actually going to put these in parentheses. So we're going to add ln of z. All right, so from here, I'm actually going to distribute that negative sign and move these exponents to the front. So this is going to be 1/2 ln of x minus 3 ln of y. I've taken this 3 and moving it to the front of ln y, and I've also distributed that negative sign to it. And then we have minus ln of z. Again, distributed that subtraction sign to the ln of z. And that's going to be our answer there. And I'll underline it just to make sure that you guys got it. All right, let's move down to this one. So we got a lot of adding, a lot of subtracting going on. So we're going to have log 7 of 3 plus log 7 of x squared. And then again, we're going to subtract. I should have written that out down at the bottom, but that's okay. I'm just going to continue it. Log 7 of 5, that is being added to log 7 of y cubed. All right, so I'll go ahead and rewrite this elongated one. We have log 7 of 3, that's going to stay exactly how it is, plus, and we have to move that 2 to the front, log 7 of x. Again, I'm going to come down here, I'm going to distribute that subtraction, log 7 of 5, and then I'm going to move this 3 to the front and distribute at the same time, so minus 3 log 7 of y. All right, so again, we're just rewriting. So let's move on to this one here. We have ln of x plus ln of y to the 1/3. We've got a cube there. And then I will write minus ln of 2 plus ln of z. All right, and again, we'll just rewrite the ln of x plus 1/3 ln of y, and I'll distribute that subtraction minus ln of 2 minus ln of z. All right, and that's going to be the elongated version of this one. All right, we have 4 more examples to do here. So we're doing the actual opposite here. We're going to be condensing these expressions. So our base is going to be log 4, so I'm just going to go ahead and write that base. We have, and again, you'll have to go reverse and move this to there, move this 3 over here as if it's a power. So we've got x, I'm actually going to write it as the square root of x over, because we are subtracting whatever's left, and then we have x minus 2 cubed. All right, on to the next one. Okay, so we're adding here, which means it's going to be a multiplication thing that we're doing here. So we have ln of x plus 1, which is going to be to the 5th power. And then we're going to end up multiplying it by x to the 6th power times x to the 6th. And I'm going to leave it just like this. Now, the ln actually needs to go with the x to the 6th as well. So if you wanted to put brackets around the entire thing, you could, or you could just leave it just like that. All right, let's look at this one down here. We have some adding and subtracting, which means we're going to have being combined by multiplication and division. So we have ln of 8 plus 2 ln of 5. So this is going to be ln of 8 plus ln of 5 squared minus ln of 10. I'm just taking my time kind of adding things together. So it looks like we're going to have ln of 8 times 25, because 5 squared is 25. We can go ahead and simplify that, over 10. All right, and when we rewrite that again, we're going to have ln of 200 over 10, and this one's actually going to condense into a whole entire number I'm already seeing. So we have ln of 20. We'll actually leave it just like that. All right, we've got one more over here. Okay, so we have log 3 of 9 to the 3 over 2, which means the square root of 9 cubed, and we'll actually be able to simplify that, and plus log 3 of 81. So let's focus on this term right here. So we have the square root, and I'm just going to write it. Square root of 9 is going to be 3, and then we have 3 cubed is going to be equal to 27. So I'm just going to rewrite this as 27. So we have log 3 of 27 plus log 3 of 81. All right, and then when this is simplified, we're going to get 3 plus 4 equals 7.